Nitrogen's hidden role in toxic algae blooms for decades, phosphorus has been the primary suspect in fueling toxic algae blooms in lakes. New research from the University of Vermont challenges this assumption, revealing that even small amounts of nitrogen can significantly worsen these blooms, impacting water quality and ecosystem health. This isn't just an academic debate. It has real-world implications for how we manage freshwater resources. The historical focus on phosphorus traditionally, lake management strategies have centered on reducing phosphorus runoff, as it's widely considered the main driver of cyanobacterial growth. Cyanobacteria, also known as blue-green algae, thrive on excess nutrients, creating blooms that can choke off sunlight, deplete oxygen, and produce toxins harmful to humans and wildlife. However, the UVM study suggests that nitrogen, often overlooked, plays a far more critical role than previously understood. New findings. Nitrogen's influence. Researchers analyzed water samples from Lake Champlain, focusing on St. Albans Bay and Missisquoi Bay. The data revealed that nitrogen levels, even in small concentrations, correlated with increased cyanobacterial biomass. In Missisquoi Bay, nitrogen levels were in some cases double those in St. Albans Bay, potentially fueling stronger bloom development. The study highlights that nitrogen isn't just about whether a bloom occurs, but also its composition, toxicity, and duration. The volatility of nitrogen. Unlike phosphorus, nitrogen is a highly volatile nutrient. It exists in various forms, both naturally and synthetically, making it difficult to predict its impact on lake ecosystems. While phosphorus runoff is relatively straightforward to manage, nitrogen's fluctuating levels, exacerbated by climate change-induced floods and extreme rainfall, pose a greater challenge. Beyond the surface, toxin production. Despite high biomass during blooms, UVM scientists found low toxin concentrations in initial samples. However, this doesn't guarantee safety. Secondary blooms can release toxins even after the primary bloom crashes. Researchers plan further studies to identify the specific cyanobacteria species present, their genetic potential for toxin production, and how environmental factors influence toxicity. The need for adaptive management. Current lake management strategies must evolve to address nitrogen's hidden role. Reducing nitrogen runoff from agricultural and industrial sources is critical. More frequent and comprehensive water monitoring is needed, especially during extreme weather events. Further research is essential to understand how nitrogen interacts with phosphorus and other nutrients to drive bloom development. Future research directions. Researchers at UVM plan to continue their work, employing high-frequency and bi-weekly sampling across Lake Champlain. They will use genetic testing to identify cyanobacteria species and assess their toxin-producing potential under varying conditions. The goal is to move beyond simply detecting blooms to predicting their composition, toxicity, and duration with greater accuracy. The bigger picture, the UVM study underscores a fundamental shift in how we approach freshwater management. Nitrogen, long overlooked, is now recognized as a critical factor in controlling toxic algae blooms. Ignoring this reality will only exacerbate the problem, threatening water quality, ecosystem health, and human safety. A more holistic, adaptive approach is urgently needed to protect these vital resources.